All right, let's just jump right into one of the biggest, oldest questions humanity has ever asked. When we look up at the night sky, does all of this just go on forever? Let's get into it, because the answer science gives us is way more mind-bending than you'd probably guess.
I mean, on the surface, it seems like a simple yes or no question, right? Is it infinite or not? But as we're about to find out, modern cosmology has an answer for us that is, well, not so simple. It's complex, it's layered, and honestly, it forces us to totally rethink what we even mean when we say the universe. So first things first, we've got to get one crucial idea on the table. When we ask this question, we're actually talking about two different things. There's the universe we can actually see, and then there's everything else.
You see, our view of the cosmos has a hard limit, a cutoff point. What we call the observable universe is this giant bubble that's about 93 billion light-years across. And why that specific size? Well, it's because the universe is about 13.8 billion years old, so light from any farther away just hasn't had the time to reach us yet. But, and this is the key, there's absolutely no reason to think that reality just stops at the edge of our little cosmic bubble. The entire universe, the whole shebang, could be way, way bigger, maybe even infinite.
Here's a great way to think about it. Imagine you're on a ship in the middle of a huge ocean. You can only see to the horizon, right? But you don't assume the ocean just stops there. Our cosmic horizon is exactly like that. It's just the edge of what we can see, not the edge of what is. So the real mystery becomes, what's out there, beyond our view?
And to even begin to answer that, we have to ask a totally different question, one that might sound a little weird at first. What is the universe's shape? Because it turns out the geometry of the universe is everything. It dictates its fate and whether it's finite or infinite.
Yep, this all comes back to good old Einstein. His theory of general relativity basically says that all the stuff inside the universe, all the matter, all the energy, is what determines the overall shape of the universe. The more stuff there is, the more space-time itself gets bent and curved.
So this whole density thing boils down to three main possibilities. First, if the density is really high, we get a closed universe. Think of the surface of a sphere. It's finite, but you could walk forever and never find an edge. Second, if the density is low, it's open, kind of like a saddle shape, and that one is infinite. And then there's the Goldilocks option. If the density is just right at what's called the critical density, the universe is flat. And a flat universe in the simplest model is also infinite.
So, for decades, this was like the holy grail for cosmologists. Which one are we? A sphere, a saddle, or a flat plane? And incredibly, the clue that would crack the case was hiding in the oldest light in the entire cosmos.
That ancient light has a name, the cosmic microwave background, or CMB for short. The best way to think about it is like the universe's baby picture. Seriously, it's the faint afterglow, the leftover heat from the Big Bang itself, and it's basically a snapshot of the cosmos when it was just a tiny infant.
And here's the brilliant part. This baby picture is covered in tiny hot and cold spots. And by measuring the size of those spots, scientists can figure out how much space has been warped over 13.8 billion years. See, if the universe was curved like a sphere, it would act like a lens and make the spots look bigger than they should. If it was saddle-shaped, they'd look smaller.
So, what did we find? After decades of work with incredible data from things like the Planck satellite, we got the answer. The curvature is, drumroll please, basically zero. It is so ridiculously close to zero that you can't tell the difference between it and being perfectly, mathematically flat.
So there it is. The verdict is in. On the biggest scales we can measure, our universe is flat. So that means it's infinite, right? Case closed. Well, not quite.
Yeah, not so fast. Just when you think you've got it all figured out, cosmology loves to throw a curveball. And here's the twist. It turns out that being flat doesn't automatically mean you're infinite.
And you're probably thinking, wait, what? How can something be flat but not go on forever? It's a great question, and the answer comes down to a really cool property of shapes called topology. So geometry is about the local stuff. Is a sheet of paper bumpy or smooth? Is it curved? Topology is about the big picture. It's about how the whole thing is connected. Is that flat sheet of paper an infinite plane, or is it maybe rolled up into a tube and connected to itself? Okay, the easiest way to get this is to think about a classic video game, like Pac-Man. The screen is a flat rectangle, right? It's finite. But when Pac-Man goes off the right edge, he pops back in on the left. That's a flat, finite universe.
Our own universe could be just like that, a 3D version of it shaped like a donut, or what mathematicians call a torus. If it were, you could fly your spaceship in one direction, and eventually, without ever turning, you'd end up right back where you started.
So how in the world could we check for something like that? Well, we go back to that baby picture, the CMB. If the universe really did loop back on itself, we should be able to see the exact same pattern of hot and cold spots in different parts of the sky. It'd be like seeing the back of your own head by looking far enough forward. So far, we've found nothing. No repeats. Now, that doesn't mean it's impossible. It just means that if our universe is a finite loop, it has to be mind-blowingly huge. We're talking at least 250 times bigger than the entire observable universe we can see.
Okay, deep breath. Let's pull all of this together. Where does all this evidence leave us in this cosmic detective story?
All right, here's what we know for sure. Fact 1, the universe has a finite age, 13.8 billion years. Fact 2, our view of it is finite thanks to that cosmic horizon. Fact 3, we've measured its shape, and it is, for all intents and purposes, perfectly flat. And fact 4, the simplest, most elegant explanation for a flat universe is that it's an infinite one.
But wait, there's more. Our leading theory for what happened in the very first fraction of a second after the Big Bang is called cosmic inflation. And one of the key predictions of that theory is that the universe should be flat. Inflation says that space expanded so incredibly fast that it basically stretched all the curvature out of it, making the universe unimaginably vast, far, far larger than what we can observe.
So, what's the final answer? Where do scientists land on this? Well, the consensus is that the universe is probably infinite. All the evidence we have, all our best theories, they all point in that direction. But, and this is a big but, as good scientists, we have to admit we can't be 100% certain. That weird possibility of a gigantic, finite, looping donut universe, it's still out there, hiding just beyond the edge of what we can see.
And that leaves us with a thought that is, well, it's just staggering. Because if the universe truly does go on forever, then somewhere out there, every single possible thing that can happen must happen. That means that somewhere, unimaginably far beyond our horizon, there's an exact copy of Earth, and on it, there's another version of you at this exact moment pondering this exact same question.